Transformer is an electromagnetic static device in which input is in form of electrical energy and output is also in electrical form. Also, the input and output both are in alternating form. Primarily, transformers are used to change level of voltage and current. For example, in case of step-down transformer, the input high voltage is transformed to a low voltage, whereas the magnitude of current is increases because input and output power has to be remain same. Working of a transformer can be understood by taking a simple example of a small piece of wire carrying current when it is connected to a battery. As a result, a magnetic flux gets set up around the conductor. If another piece of wire comes in the vicinity of this flux, an electromotive force is get induced in the conductor, which we can see here form deflection in needle of a galvanometer. But after some time, deflection becomes zero. Because both conductors are stationary, means there is no relative movement between them. This is known as dynamically induced EMF. Further, we can also experience that EMF is again induced in the second conductor when we remove battery. This is because of reduction in flux density around the first conductor, and the second conductor try to oppose this change in flux as per Faraday's law of electromagnetic induction. The magnitude of EMF induced is given by E2 is directly proportional to d phi by dt. This electromagnetic coupling between the two conductors can be improved by two methods. Number 1. By using coil on both sides instead of using single wire, this results in increase of flux. Number 2. By using a magnetic core between the coils, which gives low reluctance path to the flux and improve magnetic coupling between the coils. As you can see here, in this case, coil of left side, or we can call it primary coil, has lesser number of turns than the coil on right side, or we can call it secondary coil. And the transformer is called as step-up transformer. In this case, voltage which induced on secondary coil V out is higher than the voltage which is applied V in on the primary coil, whereas the current get reduced as the power has to remain constant. Similarly, when primary coil has more number of turns than the number of turns in secondary coil, the transformer is called as a step-down transformer, and the voltage induced on the secondary side V out is less than the applied voltage V in on primary side. The core which is practically used in a transformer is actually not a solid core. It is made up of number of thin sheets of metal called laminations. This type of construction is used to reduce eddy current loss, which occurs inside the core when it carries changing or alternating flux. As core is used to provide a low reluctance path to the magnetic flux, but the core is subjected to circulating electric currents. These circulating currents, called eddy currents, produced heating and energy losses within the core, results in decreasing the transformer's efficiency. This circulating current is produced mainly due to EMF induced in the iron core, as it is constantly being subjected to the changing magnetic field set up by the external sinusoidal supply voltage Vn. To reduce these unwanted power losses, thin steel laminations is used to construct the transformer core. Laminations are made up of highly permeable material, that is silicon steel. These laminations are assembled together to build a solid core. The resistivity of the steel sheet itself is high, reducing the eddy current losses while making the laminations very thin. The thickness of these laminations is vary between 0.25 mm to 0.5 mm, and as steel is conductor, laminations are electrically insulated from each other by a very thin coating of insulating varnish or by the use of an oxide layer on the surface. The problem with the construction, which is so far discussed here, is that the two windings are well separated from each other and there is considerable reduction of magnetic coupling and hence the efficiency of the transformer. This disadvantage can be overcome by using constructing core like this, in which the two windings are bring close to each other, thereby improve magnetic coupling between them. Hope now you have a little bit idea about principle of working of electrical transformer and about its construction.